Hello, everybody. How are you all? I hope everybody is doing well. So, this is me, and I welcome you in this lecture. This is lecture number 5 of chapter Electricity. Let's begin this lecture without wasting our time. So, here we are. So, here we will be discussing about the series and parallel connection. Now, you guys might be thinking that I also discussed these two terms in our previous slides or in our previous lectures. But here we will discuss about the series and parallel connection in more detail, and we will also try to find out the overall resistance of a circuit. Okay, so let's begin this class without wasting our time. So here we are. So in this first picture, on this first image, here the parallel circuit is given. The parallel circuit is given. Okay, so what is a parallel circuit? As we know that, let's suppose this is your battery. Okay, this is a circuit. This is a parallel connection like this. This is your bulb. This is another bulb, and these are connecting like this. So basically, why we are calling it a parallel connection? Because as you can see that these two terminals, let's suppose this is negative terminal of this bulb and this is also negative terminal of this bulb. So these are connecting to each other in parallel. Okay, these are connecting to each other in parallel. Why? Because the same sides of the bulbs are connected to each other. Okay, that's why they are in what? They are in parallel. Now, one thing is also to be known that here I have to add a minus sign. Why? Because this is a parallel circuit. And in parallel circuit, what we do, we actually connect the same terminal. So this is all negative, this is also negative. Okay, this is positive, this is also positive. So that's why this is a parallel circuit. Now, in parallel circuit, the voltage is same. Let's suppose the voltage of this battery is V. Now, the voltage of this bulb will also be V, and this bulb, voltage of this bulb is also be V. It means the same voltage will go to all two bulbs. Okay, I hope guys you get my point. But in series circuit, what happens? Let's suppose this is your series circuit. This is your battery. Okay, this is a bulb. This is again a bulb. This is minus, this is plus, this is plus, this is minus, this is again plus, this is again minus. So basically this is a series circuit. So in series circuit, what happens? This voltage will be divided on these two bulbs. Okay, so the combined voltage of this bulb will equal to this voltage of this battery. But in this case, when we discuss parallel circuit, what happens? This voltage goes to these two bulbs individually. If you calculate voltage on this bulb, then that is V, and on this bulb also, the if you calculate the voltage, this will also be V, and the voltage of this battery is also be V. So I hope guys you might understand what is the difference between the parallel and the series circuit. So in this picture, the same thing is shown, that this is negative terminal, this is also negative, this is also negative. Okay, this is positive, this is positive, and these two positives are connected to the positive of the battery. Now here in this case, this is positive, this is connected to the negative of bulb first, and this is connected to the positive, then this positive is connected to the negative of this bulb, and this positive is connected to the negative of this battery. So different terminals are connected here, different. and here same terminals are connected. So I hope guys you understand this series and parallel connection. Now let's move ahead to the next slide, and here we will let's understand current and potential difference in series. So this is a series connection. Okay, this is a series connection. Why this is series connection? Because these cells are connected. Let's suppose this is negative, so this will be positive, this will be negative, this will positive, this will negative, and this will positive. So different terminals are connected to each other. Now what is this? This is basically a switch. This is basically what? This is a switch. So what is the work of switch? As we also know that the switch which we find in our houses, what is the work of those switches? Basically, whenever we turn on the switch, what happens? Our appliances starts to work. And whenever we switch off, what happens? Our appliances stop working. So why does it happen? Basically, we know that to flow current in a circuit, it is quite essential that the circuit should be completed. It is very essential that circuit should be completed. So what happens if you break the circuit? Then the current cannot be flown in this circuit. Okay, the current can't flow in this circuit. Why? Because this is break circuit. Okay, so if let's suppose there is a battery you connect to this circuit, this is a bulb and you want this bulb to glow, then you have to complete this circuit like this. So the work of the switch is same. What happens when you switch on? So it simply means that your circuit gets completed and your appliances starts working. But as long as your switch is off, so it simply means that the circuit in this condition is not completed, or the circuit is break. You can say the circuit is broken. So in this condition, the current will not be able to flow in the circuit. So I hope guys you might understand the work of a switch. Whenever you switch on, the circuit is completed, and whenever you switch off, the circuit gets broken. I hope you got it. Now let's move on. Okay. So let me erase it. So basically here what is our motive? We are trying to find out what happens when we connect the appliances in series. What happens with current and potential difference on those appliances? Let's suppose the voltage here is 20 volt. Okay, so in series connection, this 20 volt will be divided in these two bulbs, in these two bulbs. But when you connect these bulbs in parallel, let's suppose you connect these bulbs in parallel like this, then what happens? This voltage V, which is 20 volt, will directly go to these bulbs. It means if you calculate the individual voltage of on these bulbs, then on this bulb first you will get 20 volt, and this another bulb, if you calculate the voltage of this other bulb, will also be 20 volt. So it means this voltage will directly go into these bulbs. So I hope you get it. Now why this happens? Let's apply a very simple logic. What happens? Here you are connecting these two bulbs directly to the cell. Okay, this bulb is connected directly to this bulb. Okay, and here also this bulb is connected directly to the cell, because this positive is connected to this bulb, and this negative is connected to this bulb directly. So that's why here you are giving them the direct voltage. But in this case what is happening? Why voltage is divided? Because these bulbs are not connected directly to this voltage. This bulb is connected to this, and then this bulb is connected to this cell again. So that's why the voltage in this case is being divided. I hope guys you get my point. Now let's talk about currents in this case. So what happens? Let's suppose I current is flowing in this circuit. So in this whole circuit, I current will keep flowing. The value of current will not be changing. Why? Because this is a series connection. Okay. If you want to calculate the value of current, then it will be I, and this I will remain same in this circuit. But in this case, when I talk about the parallel connection, what happens? Let's suppose I current is going in this circuit. So here the current will be divided in two parts. Let's suppose I1 current is going here and I2 current will going here. Okay. And after passing through these circuits, it will again combine and gives us a value equal to I. So this happens in parallel circuit. So what is happening in parallel circuit? The current, the value of current is not same. In this bulb, the value is different. In this bulb also, the value is different. Now, you might think, then how will it be divided? So basically, you can calculate the values of current if you know about the resistance of these bulbs. Let's suppose the resistance on this bulb is 10 ohm. Now, in this case, what is the value of current on this bulb? So it is as simple because we know that I is equals to V upon R. I is equals to V divided by R. So let's find out the value of current in this case. The voltage we are giving is 20 volt and the resistance is 10 ohm. So what is the value of I? The value of I is 2 ampere. Okay, the value of I is 2 ampere. Now let's find out the value of this current I2. This is the value of current I1. Okay, and this is the value of current I1. But now we want to calculate the value of I2. Now how can we do that? We know that I is equals to V upon R. Now what is the value of this voltage? 20 volt. Now what is the value of resistance? Let's suppose here the resistance is 20 volt. The resistance, sorry, 20 ohm. Okay, what is the unit of resistance? Ohm. So let's suppose the value of resistance here is 20 ohm. So you will simply put it here 20 and 20 by 20 cancel out. It will give us 1. So now the value of current I2 is 1 ampere. The value of current I2 is 1 ampere. And what is the value of current I1? That is 2 ampere. So here 2 ampere current is flowing. Here 1 ampere current is flowing and they will combine and give us 3 ampere. And from here 3 ampere current was flowing. So this 3 ampere was divided in 2 ampere and 1 ampere. So basically you don't need to be scared of it. It is very simple. I just want to explain that the current is getting divided according to their resistance. If resistance is higher, then the current will lower. If the current is higher, sorry, if the resistance is higher, then the current is lower. If the resistance is lesser, then the current will be higher. Okay. But in this case, let's talk about this parallel connection. In this case, what happens? Let's suppose the resistance here is 10 ohm. Okay. And let's suppose the resistance here is also 10 ohm. Now, if you want to calculate the voltage on this bulb, because the voltage is not same here, the current definitely is same. If you want to calculate current flowing in this bulb 1, then definitely it will be I, and here also it will be I. But if you want to calculate voltage, then definitely it will different on these two bulbs. This bulb has different voltage and this bulb has also different voltage. Now I will teach you how to calculate voltage, how to calculate current on these connections, on these parallel and series connection. Okay, but in the later slides. For now on, let's move ahead. And here the motive to understand all these things, or the motive to teach and to explain all these things, is to give you a basic idea that in series connection current is same but voltage is different. Let me write it here for you. In series connection, V is same but, sorry, I is same but V is different. Okay, but in parallel connection it will be opposite. V would be same and I is different. So now let's move ahead to the next slide and let's try to understand current and potential difference in parallel. So what happens? Let me change the pen. We know that current in parallel is different, and I will not explain it again here because I had already explained in the previous slide. But here you just need to remember that the current is different in parallel connection, but the potential difference is same. Okay, potential difference is same and is same as the battery. Let's suppose the potential difference of the battery is 20 volt, then this 20 volt will directly go on this bulb and also on this bulb. So these two bulbs have the same voltage and that will be equal to this cell. Now guys, after understanding this, let's move on to the next slide and let's try to understand the combination of resistance. It is very, very, very important part. It is like a spirit of this chapter. Combination of resistance. You see, it is very important. Lots of numericals will be coming on the behalf of this topic. So you should have a basic understanding of this topic. So let's start. Let's try to understand what is a series combination. So basically, we know that whenever we connect something in series, okay, then what happens? We have to connect their different sides to each other. So now this is a resistance. Okay, this is a resistance R1, and this is also a resistance R2. This is also a resistance R3, and these are connected in a series. As you can say, these are connected in series. Now what happens? We have to calculate, we have to calculate the combined resistance of the circuit. So basically, what we have to do, if we connect simply a circuit R, okay, if I remove all these three resistance and instead of it, or you can say in place of these three resistance, if I connect R, then what will be the value of that resistance R? Okay, or we can say I want to calculate the overall resistance here. What is the overall resistance? So how can I do that? It is very simple. Basically, I know that in series what happens, current remains same in the circuit. Current remains same in the circuit. But what is different, and that is voltage. Voltage is different in each resistance. So let's suppose At this resistance R1, the value of voltage is V1. The value of voltage is V1. And let's suppose the value of voltage on R2 is V2. And here the value of voltage is V3. Now, if I want to calculate the overall voltage, then it will be V1 plus V2 plus V3, and that will be equal to voltage V. Now, I know that the current is same in this circuit, and if I want to calculate V1, then I can simply calculate it by the Ohm's law. What is the statement of Ohm's law? That voltage is proportional to the what? Current. And when I remove proportionality, then I added a equal to sign, and I also added a constant, that is R, and R is our resistance. So what if I want to calculate the potential difference on this resistance R1, then what will I do? I will simply write it like this. V1 is equals to IR1. Okay. Now, if I want to calculate V2, then V2 will be similarly IR2, and what will be the value of V3? It will again as similar IR3. Okay, now if I write the value of V, this P, then it will equal to current I and the overall resistance. If I remove all these three resistance, and in place of these resistance if I connect a single resistance, then that is R. Okay, it is the value of the overall resistance, or you can say a combined resistance. Combined resistance. So now let's put all these values, in this equation. Let's suppose this is equation number first. So if you add all these values, it will give you IR1 plus IR2 plus IR3 is equals to IR. Now you can take I common, and this will give you R1 plus R2 plus R3 is equals to IR. Simply cancel out I to I, and it will give you the results, and that is R is equals to R1 plus R2 plus R3. So this is the combination of resistance, and this is the value of combined resistance. So in series, what happens if you want to calculate the overall resistance, and if the resistance are connected in series, then what do you have to do? You have to simply add all the resistance. Okay, let me give you a basic idea about it. Let's suppose this is a circuit where a 10 ohm, okay, let me erase it. Okay, so this is a circuit where I connected a 10 ohm resistance, a 20 ohm resistance, and a 30 ohm resistance. Okay, and this is connected with a battery. This is 10 ohm resistance, this is 20 ohm resistance, this is 30 ohm resistance. Now if we want to calculate the overall resistance, then how would I calculate it? I will simply add all these resistance, 10 plus 20 plus 30, and it will give you 60 ohm. So this 60 ohm is the combined resistance of this circuit. I hope guys you get my point. Now let's move on to the next slide, and let's try to understand the combination of resistance in parallel circuit. This is also very important. But if we understand the combination of series, the combination resistance of series, then it will be easier to us to understand the combination of resistance in parallel combination. Okay, so let's try to find out how can we do that. So basically, this is an image of a parallel combination. This is an image of a parallel combination. So here I connected a battery and I also connected these three resistance R1, R2, R3. These are the same resistance as we connected in the previous slide, but that time the connection was the series connection. But here the connection is parallel connection. So here in this case, we have to calculate the combined resistance. So how can we do that? We know that in series what happens, the voltage is same. The voltage remains same in all the circuits. Sorry, in parallel, the voltage is same in all the resistance, okay, which are connected in parallel. But in series, the voltage is different. Okay, and here in the parallel connection, current is divided. It means current is not same in all the resistance. So if I want to calculate this current I, then I have to add all these individual currents passing through these resistance. I1 plus I2 plus I3. Okay, and this will give me the value of I. I hope you guys getting my point. I again repeat my statement that this I is getting divided in these three currents. So if I add these three currents, then this will give me the value of current I. Okay. So now I know that the voltage across all these three resistance is same because these are connected in parallel. If I calculate voltage for it, it will be V. If I calculate voltage for this I3, it will again be V. Okay. So this is the overall voltage. Let's suppose this is also V. Okay. And here I am writing R. Now you tell me what is the meaning of this R. So this R is the combination resistance, or you can say is a combined resistance of this circuit. Now what is the value of I1? I will simply write it V upon R1. What is the value of I2? I will simply write it V upon R2. What is the value of I3? I will again simply write it V upon R3. Now you might wonder that how can I writing this? Basically I know that V is equals to IR. So if I multiply this R here, if I cross multiply it here, then it will go in divide and I will get this formula I is equals to VR. So if you want to write current for this resistance, then I will write simply V upon R1. If I want to write current for R2, it will be simply V upon R2. And if I write current for this I3, it will again be V upon R3. Okay, this is for R3, this is for I2, this is for I1. So I simply put these values in this formula, and you can see that this V is common, so that's why it will be cancelled out. And here you will get 1 upon R is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. And this is very, very, very important. This is very, very important because in the previous slide we saw, let me show you the previous slide. Okay, so here you can see that the combined resistance was R is equals to R1 plus R2 plus R3. But in this case, when I discuss the case of a parallel connection, then you can see that the value of combined resistance will be 1 upon R1 plus 1 upon R2 plus 1 upon R3. So this is the formula which will be used in numericals. Whenever we will solve numericals, we will use these formulas. So I hope guys you get my points. Okay. Now it is enough for this lecture, and we will be discussing later concepts in the later class. So thank you so much guys. I'm ending this lecture here, and bye bye.